Hello, and welcome to this explainer. Today, we are putting a highly analytical, data-driven lens on one of the most fascinating sky anomalies documented throughout human history. Have you ever wondered if those ancient myths about strange things happening in the sky might actually just be deeply misunderstood science? Well, we're going to explore exactly that. We're taking a very structured look at how historical mysteries are finally being explained through modern atmospheric physics.
I want you to imagine something for a second. You step outside on a freezing, dead quiet winter night. You look up at the sky, and instead of seeing our single familiar moon, you clearly see two. It sounds completely impossible, right? Like something straight out of a sci-fi movie. But the wild part is, this bizarre event is actually historically documented. Multiple cultures, completely disconnected from one another, have recorded seeing multiple moons in the night sky. So, what on earth were they actually looking at?
To answer that, we have to turn to a fascinating scientific framework called the Triune Harmonic Dynamics, or THD hypothesis. This was developed by researcher, inventor, and author Kevin L. Brown. Now, the THD hypothesis proposes that these two moon events, they aren't magic, and they definitely aren't parallel universes. Instead, Kevin L. Brown's framework explains them as measurable atmospheric light splitting. Basically, it's a structured, physical process where the sky itself creates a perfect optical illusion.
Okay, let's dive right into this. Here's our roadmap for today. First, the two-moon mystery. Second, the THD framework. Third, building atmospheric pressure. Fourth, historical data. Fifth, testing rules. And finally, real-world impact.
Section 1. The two-moon mystery. History's sky anomalies.
Before we can understand the science, we really have to look at the data. For centuries, ancient cultures viewed these strange events as supernatural warnings. We have Roman military reports describing dual moons during times of intense social instability. We also have incredibly detailed Chinese astronomical records documenting multiple moons right during rocky dynastic transitions. And finally, medieval European observations note double or even triple moons during brutal winter conditions. What connects all of these? Well, they almost always happen during extreme cold or high-stress environments.
Section 2. The THD framework, turning myth into science.
This is where we shift our perspective from supernatural myths to strict atmospheric physics. The core concept here is that this is not magic. Under very specific, extreme pressure conditions, the Earth's atmosphere physically acts as a massive optical lens. It bends light so intensely that it temporarily splits the moon's visual signal. You are still looking at one moon, but the sky projects a flawless, ghostly duplicate right next to it. It's like a giant natural prism. Let's move to how this actually builds across three distinct phases. Step 1 is the base phase. This is just your normal everyday sky with a single moon. Step 2 is the pressure phase. This is where things get really unstable. Dense ice crystals and layers of freezing air start stacking up, almost like invisible glass. Finally, step 3 is the integration phase. The pressure hits a breaking point, the sky acts as a prism, and boom, the single beam of moonlight splits into two clear projections.
Section 3. Building atmospheric pressure. The mechanics of the split.
So what exactly forces the sky to behave like a giant prism? Well, it requires a very specific recipe of physical ingredients. First, you need incredibly thick hexagonal ice crystal density floating in the air. Second, you need intense vertical thermal inversion, which simply means a sudden layer of warm air gets trapped between freezing cold air. And third, the lunar angular elevation matters. The moon has to sit at the exact perfect angle for the light to hit those ice crystals and bend correctly.
If you were actually standing outside right before the moon split, what would you see? These are the pre-transition indicators. You'd notice thick, glowing rings or high-density halos forming around the moon. You'd feel a sudden sharp drop in temperature. You'd notice the moon is resting at a low angle, and suddenly the crisp night air would look hazy as the air's transparency rapidly drops. That is the atmospheric pressure building right before your eyes.
Section 4. Historical structural transitions. Observing the data.
Now, let's look at how Kevin L. Brown's THD framework actually measures this light-splitting behavior, because it represents a major leap forward from older models. The standard, older view treated these events as simple, passive optical distortions, just kind of random light scattering. But the THD model shows us something entirely different. It models the atmosphere as a dynamic, high-pressure state that actively reorganizes light. It's a highly structured, mathematical reorganization of the moon's visual signal.
Section 5. testing and falsification rules, proving the science.
For any framework to be taken seriously as real science, it absolutely must be highly testable with strict rules for how it could be proven wrong. And according to researcher Kevin L. Brown, the hypothesis is entirely false if any of the following happen. If dual moons appear on a warm night with 0 ice crystals. Or if instruments show the atmospheric pressure thresholds are hid but the moon doesn't split. Or finally, if the second moon appears in a place that defies basic optical geometry. These strict rules prove the scientific rigor behind the framework.
Section 6. Real-world impact today. Why this matters.
Now, you might be wondering, why does understanding an ancient two-moon mystery actually matter to us right now? Well, the practical, modern-day applications are actually huge. By understanding exactly how the atmosphere can warp and split light under pressure, we can dramatically improve aviation visibility systems, literally making flights safer during freezing weather. We can write better software to correct optical distortions in deep space telescope data. And we can heavily enhance our climate optics forecasting, predicting exactly how light and lasers will behave in extreme environments. To wrap up everything we've covered today, it all comes down to this definitive, analytical test statement. If atmospheric pressure passes the critical threshold and no light splitting happens, the hypothesis is falsified. It's a brilliant, clear-cut line in the sand that grounds this entire phenomenon firmly in the realm of hard, measurable science.
So the next time you step out into the freezing cold of a brutal winter night and you notice a thick, glowing halo forming around a low-hanging moon, take a closer look. You now know the physics, you know the variables, and you know the history. Will you be the next person to see the sky split? Thank you for joining me on this explainer. Keep looking up and keep asking questions.